Hello, welcome to the Hwk Solutions video for section 4.5b. We're going to work on page 296, number 33 through 41 odd. These are all integration by substitution involving trig functions. And I was able to get 33 and 35 on the board ahead of time. So for a 33, we have sine 2x dx. If we let u be 2x, du is 2 dx. Well, we just need it to be dx, not 2 dx. So if I divide both sides by 2, I'd have half of du is dx. Then I can put that half out front of the integral that is the substitution integral. And I can write it as sine u du. Okay, so you know that u is 2x and du is 1/2 du, we got the half out front, is dx, and so this is the exact same thing as this in terms of u. Just if you're not sure you did it right, think through it, write it out. And now that's easy to integrate. The antiderivative of sine is negative cosine. Now I brought the 1/2 down. I put a times there so I don't accidentally make it minus cosine. But okay, so that's going to be minus 1/2 cosine u plus c, and then we have to substitute the u back in, which is 2x. Now, if you want to take the derivative of that to check, the derivative of cosine is negative sine 2x times 2, the derivative of the angle. That would make your 1/2 go away, and the two negatives would make a positive, and you'd be right back to that. All right, 35 looks nasty, but it's not too bad. We have 1 over theta squared times cosine 1 over theta d theta. If we let u be 1 over theta, if you take the derivative of that, you get minus 1 over theta squared d theta. And you wonder, how did I get that? Remember, 1 over theta is just theta to the minus 1, so the derivative of that would be minus theta to the minus 2, which is minus 1 over theta squared. So that's how I got that. Okay. But I needed it to be positive 1 over theta squared, so I multiplied both sides by negative 1. All right, and then that got what I needed. So that negative I have to bring out in front of the substitution integral. So we know that 1 over theta squared d theta, so this part and this part, that's du. And then cosine u. So they're the same thing. The antiderivative of cosine is sine. But I've got that minus out front, so it'd be minus sine u plus c. Substituting 1 over theta back in for u, I'd have minus sine 1 over theta plus c. You could take the derivative of that. That'd be minus cosine 1 over theta times negative 1 over theta squared. The negatives would cancel, and you'd be right back to the beginning there. Okay, that does the first two. Let's take a look at 37. So 37, we have sine 2x cosine 2x dx. Now this one is not going to work if you pick u as just 2x, because du would be 2, and that's not sitting in the problem. Let's pick u to be sine 2x. If we do that, then du is 2 cosine 2x. Right? Because it'd be cosine 2x times the derivative of the angle, which is 2. Now, I needed to just be, and forgot the dx there, I needed to just be cosine 2x dx. All right? So, if I divide both sides by 2, I'd have 1/2 du is equal to cosine 2x dx, and I'm in. So we can rewrite this integral as 1/2. So we're just rewriting it in terms of u. This part, cosine 2x dx, that's du. Sine 2x is u, so I can just write it like that, u du. Well, that's a real simple integral. And think about it. Sine 2x is just u. So it's not sine u this time. The whole trig function sine 2x is u. So that's going to be 1/2 times 1/2 u squared. Because the derivative of 1/2 u squared is u. So that's going to be 1/4 u squared plus c. So that's 1/4. And then u is sine 2x, right? So sine squared 2x plus c. All right, so I'm going to go ahead and check this one. Let's think about this as 1/4 sine 2x all squared, because that's the same thing, plus c. The derivative of that would be 2 times the fourth is 1/2 times sine 2x to the first power times the derivative of sine 2x cosine 2x times the derivative of 2x, which is 2. So the 2 and the half cancels out, and you just get sine 2x cosine 2x, and you're back to the beginning. So it does work. Beautiful. 39. So that's tangent to the fourth power of x times secant squared x. So what could you pick so the derivative's sitting in the problem? Well, how about we let u be tangent x? And then du is secant squared x dx. All right, sitting right there. Du is sitting right there. I don't have to adjust anything. So I could rewrite this in terms of u as u to the fourth du. So that's 1/5 u to the fifth plus c. Can't leave it like that. That's 1/5 tangent x to the fifth. The book would probably write tangent fifth x or tangent 5 in front of the x, okay? Plus c, but either way is fine. If we check that, I got 5 times 1/5 is 1, so I would have 5 times tangent, not 5, excuse me, 1. 5 times a fifth is 1, times tangent x to the fourth power times secant squared x, the derivative of the block, tangent x, and that's this, tangent to the fourth x times secant squared x, so that works. Look at us go. All right, and then number 41. Okay, so we've got cosecant squared x over cotangent cubed x dx. Okay, what can I pick for a u if you take the derivative of it is sitting in the problem? How about cotangent x? Now remember, this is just cotangent x cubed. So if we pick cotangent x, the derivative of that is minus cosecant squared x dx. And that's right up top. It's sitting up there. All we have to do is multiply both sides by -1, and we have what we need. So I've got to adjust with a minus out front. But then I would have cosecant squared x dx is now du over u cubed. Okay, because it's so it's u, so we've got to cube that. That's the same as u to the -3 du. So integrating that, don't forget that minus out front, you would have u to the -2. But I'm going to need a -1/2 out front. So -2 times -1/2 is 1 times u to the -3. So and then I can't forget that negative there. This is easy to mess up. So that's going to be a positive 1/2 u to the minus 2. If we bring that u to the minus 2 downstairs, it's 1 over 2u squared plus c, which is 1 over, if we substitute cotangent x, right, cotangent squared x plus c. All right. Let me double check my answer to see if I messed anything up here. Nope, looks like I got it. Okay, so there you go. All right, we could check that by rewriting that as 1/2 cotangent x to the minus 2. Let's do it like this. Right, it's the same thing if we move the cotangent up and take the derivative of that. So negative 2 times 1/2 is just negative 1 times cotangent x to the minus 3 times the derivative of cotangent, which is minus cosecant squared x. The negatives cancel, or not cancel, but two negatives make a positive, and you'd end up with cosecant squared x over cotangent cubed x, which is what you got in the beginning. So the check works out. Everyone's happy. We can stop the video. I hope this helped if you had any trouble. And I will talk to you on the first test review video.